in order to prove things about geometry, we first of all need to make sure that we all remember some of the terms and definitions and vocabulary and some of the postulates that we had last chapter. So, does everybody remember segment addition? Segment addition said that if B was between A and C on a segment, then the distance between A and B plus the distance between B and C is equal to the distance between A and C. This part plus this part equals the whole thing. Makes sense, right? Okay, so let's practice that. On this next box we have, or on our next slide, we have the distance between A and B plus what gets me the distance between A and C? BC. Okay. The next one says, what plus what will get me the distance between G and I? Yep, GH and HI. Okay. The next one says, what plus the distance between E and F gets me the distance between D and F? What plus the distance between E and F gives me the distance between D and F? DE. And lastly, what can we write for this one? Yep. JK plus KL, JL. Okay, that was segment addition. So anytime we're working with segments and adding up portions of it, we're going to use segment addition as our reason. Okay, easy enough? All right, next one. What about midpoints and bisectors? So midpoint, remind me, what was that all about? Splits it into two pieces, right? It is making it into two equal parts, right? So a midpoint is a point that's midway between the endpoints, okay? And it just comes from midpoint, middle point. And bisector, what did a bisector do? Yep, it cuts it into two parts. And a bisector could be a point, it could be a line, it could be a ray, it could be a segment. So all of those things can split a segment up into two equal congruent parts. Okay? So we just have to remember that vocabulary. So our next slide says that N is the midpoint of segment MO. So what two distances will be equal? Yeah, MN and NO. Because it is the midpoint, that means we have two congruent segments, and those segments have equal distances. Okay, next one. Q is the midpoint of PR. Q is the midpoint of segment PR. So which two parts are equal? PQ and QR. Okay. Now, we'll come back and talk about these bisectors and which one's the bisector. But one last one. T is the midpoint of SU. Okay. So, Thomas, what are the two parts that are equal to each other? TS and TU. Is it okay to call it TS and TU instead of ST and UT? Absolutely. We can change those orders, and that doesn't change a thing. Okay. Now, which part was the bisector of MO here? What did the bisecting? Point N. What did the bisecting of segment PR here? Line AB. If someone said line AB, what's the symbol for a line? A segment with two arrows on top. Someone else may have said line BA, right? Could we have said line AQ? Or QB? Or line M? Okay. when we write line M, we have to remember that it's has to be, we can't use the symbol anymore. We use the word line. Otherwise, we have to have 2 points to make a line. Okay? And then finally, what was the bisector of SU, Ariel? Ray, TA. Very good. She used the endpoint and told me what direction it was going in and the right symbol. Okay? Good stuff, right? We remember this stuff. Stuff from chapter 1. Okay? All right. Remember angle addition? Our angle addition postulate, and again, a postulate is nothing more than something we don't have to prove. We can use it to help prove other things, but it's something that we just have to accept. And a angle addition postulate said if ray BD is inside of angle ABC, then the measure of angle ABD plus the measure of angle DBC has to equal the measure of the whole angle ABC. Small angle plus small angle equals whole angle. Okay? All right, so we have the measure of angle ABD, A to B to D, plus what will get me the measure of angle ABC, the whole angle? DBC. Why did you say DBC? What has to be, what's important when we name angles? What has to be in the middle? The vertex. Always have to have the vertex in the middle. We could have called it CBD, but the vertex has to be in the middle. Okay? Giovanni, what are we going to add up to get the measure of IJK? IJL and LJK. Very good. Okay. And Zach, what are we going to need to add to the measure of angle HFG to get the measure of angle EFG, this whole angle? EFH. Very nice. Okay. And Tyler, what are we going to add to what to get what? And then we go back and put measure of angle, and measure of angle. Make sense? Remember this stuff? All right. So, just like segments can have bisectors, angles can have bisectors as well. Okay? When we heard bisector, we think of bi meaning two, right? Sector, two sections, right? So 2 equal sections here. So an angle bisector will cut what in half? We're cutting a segment in half, a line in half, an angle bisector. If this is my angle, I'm going to cut that angle in half, aren't I? And so I want to have both of those angles congruent. So it's going to cut an angle in half. And an angle bisector can be a ray, or it can be a line. Okay? I guess it could be a segment technically too. All right, here we go. So vertical angles. This is where we get to tell you what you already know. Okay? First of all, 2 angles whose sides are opposite rays are vertical angles. I made one of them in blue, 1 pair of opposite rays, 1 pair of opposite rays in gray. Vertical angles only share V for vertical, V for vertex. They only have a vertex in common. Two intersecting lines or opposite rays only having a common vertex. So here's what you already figured out, but we haven't formally presented it yet. Angle 1 will be congruent to angle 2 because they're vertical. And angle 3 will be congruent to angle 4 because they're also vertical. And we'll use that a lot, over and over and over again. Okay, vertical angles are congruent. So you look at each of those rays, find their opposite rays, you have two new angles, or two new rays, two new angles, and those are vertical angles. Intersecting lines only share a vertex. Okay, so since vertical angles are congruent, look which angle is going to be congruent to angle 1. Angle 2. Angle 2 is only sharing a vertex, or does it share a ray? It shares a ray, right? So those are adjacent angles. That means they can't be vertical. So which one only shares a vertex with angle 1? We're looking for the one that's opposite it on the other side. 4. Okay, so if that helps you think of vertical angles as being opposite of each other, then do that. Okay, so angle 4 is the one that is only sharing a vertex with angle 1. So these two are congruent. Okay. Dara, which one is congruent to angle 2? Angle 3, because angles 2 and 3 only share a vertex. They're opposite each other. So those two are congruent. Okay. Questions about this slide? Feel good about this one? All right. Let's pick on page. Angle ABC will be congruent to which angle? CBD, are they opposite, only sharing a vertex? ABE is this one, and CBD was this one. But which one only shares a vertex with angle ABC? Good. EBD. Does everyone see why? Okay, they have nothing else in common, just that touch point, just that vertex. So EBD or DBE. Okay. Next one, Jasmine. Which one is going to be congruent to angle ABE? Erase. A to B to E. CBD. CBD only shares a vertex with it. It's opposite it. It only shares a vertex, so they will be congruent. Questions on this slide? Okay. All right. Who haven't I picked on yet? Erica, can you give me two angles that are congruent? XVW. Trying to write a Y. XVW. And I'm sorry, which one did you say? YVZ. Does everybody agree? Do those two only share a vertex? Absolutely. Okay. So these two are congruent. We make a single arc to show that those two are equal to each other. Haven't picked on the other Zach yet. Zach S, what are my other two angles that are congruent? WVZ and XVY. Very nice. Okay, so we can show those are congruent by using two arcs to show those two have the same measure. Thank you. Okay. What questions do you have on this slide? Okay. All right, give you a few moments. Show me what you learned. Yes. We are going to do talk about how to prove some things. So we'll grab our student journals next. Let me sign planner. Okay. Everybody have these done already? Nope, not quite. These three on the very bottom. Let you do them first. Let you think. Mm-hmm. Wait, let me finish presenting. I know we got some proofing to do of some geometric proofs. Okay. All right, we're good. So number one, here's a hint. Draw that segment for me. Got some room in your margin. So if they don't give you a picture, it's harder to do, especially if you're a visual learner like I am. We have a segment XY, and Z is the midpoint. So where do I want to put that Z at? In the middle. Now write your congruence statement. So Hannah, what did you put down for this one? Good. And when we say congruent, that means that we want the segment marks above them. When we say equal, we don't use the segment marks because that would mean the distance between X and Z equals the distance between Z and Y. But the two segments are congruent. Okay. All right, next one. Using the figure at the left, we want to write an angle addition equation. So Jaden, what did you have for this one? Good. Very nice. We didn't have a lot of room for our measures here. Very good. Okay. And then, what else haven't I picked on? I haven't picked on Mackenzie yet. How about this one? What's one pair of vertical angles? 1 and 3. And Jake, what's another pair? Very nice. Okay. Slight distinction. When we're saying angles are congruent, we use the congruent symbol. If we want to use the equal symbol, we say the measure of angle 1 equals the measure of angle 3, and the measure of angle 2 equals the measure of angle 4. Okay? So everybody's good with this stuff? Remember it? All right, we're going to prove some things with it. So I'd like you to open your student journal to page 54. Thank you. Sign this and let me give you a copy of the notes sheet, Andre. There you go. All right. On page 54 of your student journal, we're going to start talking about how to prove things geometrically. Okay, so yesterday we proved algebraic proofs. We started with what we knew, which was algebra, and we knew how to solve problems by finding out what x was, and we knew the steps behind that. Okay, page 54 of your student journal. We're going to do some of these together. So the very first step of every single proof, okay? I'll lash you with a wet noodle if you don't do this first step, okay? Some people are going to throw up their hands and say, I don't know how to do proofs. But you do know that you can always write the given information. So the first step was done for you. They wrote the given information and they wrote given. So they told us that the distance between A and C is equal to the distance between A and B plus the distance between A and B. Okay? This equals this, given. Okay? Then we also know that the distance between A and B plus the distance between B and C is equal to the distance between A and C, right? How do we know that? What did we just talk about a little bit ago? Yeah, we're just adding segments, right? We're adding 2 segments up to get the big one. So that is called, what was it called on your paper? Awesome, segment addition. Okay. Now, we have 2 statements here. This and this. Okay? How can we get from those 2 statements to this? I see these here, right? And I see these things here. What do they have in common? How could we get here to here? What do they have in common? They each equal AC, right? Okay. So if you have 2 equal players in a football game and one of them got injured, what can you do? Put the other one in. What do we call that? What is the substitution, right? Same thing here. We have 2 equal values. They're both equal to the same thing, right? So from yesterday when we took our notes, we had substitution. And that's our reason for this one. We had something that looked like transitive yesterday too, right? Could we have used transitive here? Are these 2 guys the same? No. So we can't go from here to here, right? So this isn't is not a classic case of transitive. We have to use the word substitution here. Okay? All right. Next. How do we get from here to here? Someone said it. Not commutative, because we're not changing, we're not adding the same thing to. So what's going on here? That looks like that, right? That looks like that. So what did we do to make that go away? Subtraction. Someone said subtraction a bit ago. Okay. We took away AB from both sides, didn't we? Congratulations, you've just done your first geometric proof. Means you're well on your way to being awesome geometry students. Okay? All right, here comes the next one. A geometric proof means that we have a table with statements and reasons, and we start out with our givens, And then we use information knowledge from definitions, theorems, postulates that we already know to come up with what we're trying to prove. So the very first statement is always you're given. The last statement is always what you're trying to prove. And you give me reasons and justifications along the way as you move from here to here. Okay? All right, next one. Got a busy drawing up there. And they told us that the measure of angle 1 is equal to the measure of angle 3. That's why we have this little arc here. Okay? And we're trying to prove that EBA, measure of E to B to A, the one in red, is congruent to C, the measure, or is equal to the measure of C to B to D. Trying to prove that the red one and the green one have equal measures. Okay? So the very first step of every proof is always the given, write the given. So they told us we've got given here. Okay? What were we given? Right? Okay? And then they helped us out. They said, okay, to get there, we're going to do some things. We're going to say that the measure of angle EBA, my red one, is equal to the measure of 2 plus 3. Okay? This big red angle is equal to EBD and DBA, 2 plus 3. I just didn't want to have to write so much. They put some letters, some numbers in there. Okay, that was by angle addition. We talked about that a little bit ago. Okay, and the next one was EBA equals 2 plus 1. EBA equals 2 plus 1. So from these two pieces, EBA is 2 plus 3. 1 equals 3. So do you see that they just substituted 1 in for 3? Okay, that's substitution. These two are equal, and these two are equal. So in place of 3, they put 1. Okay? Now here's where your commutative comes from, Jaden. Okay? Commutative property of addition says that we can change the order in which things are written. Okay? So, what do you think the measure of angle EBA will be if we want to change the order in which these guys are written? Yeah, 1 plus 2. Okay? Commutative says you can change the order. It's a terrible B. Okay? All right, next. Well, the measure of angle 1 plus the measure of angle 2 is going to become what? This little guy plus this little guy. Very good. Measure of angle CBD. And that's angle addition again. Okay? So we're still trying to get CBD here, right? And we're trying to get EBA here. Do you see that EBA equals 1 plus 2? 1 plus 2 equals CBD, right? So EBA equals CBD. Forgot my angle mark. Because we can get rid of the redundancy, can't we? We have these two guys in the diagonal, so we can eliminate that redundancy just like syllogism did, right? And now we have EBD equals CBD by transitive. And if you had said substitution, I'd give you that point. Okay, I wouldn't count it wrong. So on a problem like this, we can have 1, 2, 3, 4 points, right? And if you don't do anything at all, you get 0 points. But if you write down the given, and you write down what we're trying to get to, you're 50% there, right? 2 out of the 4. Change the order of addition. So if you have two numbers that are being added together, commutative says that you can change the order in which they're written. Instead of 2 plus 1, we can call it 1 plus 2. Okay? Other questions on this slide? Feeling good? All right, second proof down. One more. Now we don't have any guidelines. Okay? So we're going to make a table. What goes at the top of the first side, the left side? Before that, the very top heading. What are the statements and reasons? Okay, so we're going to put statements up here and reasons over here. Okay? So we've got our framework. Now what's the very first thing we always write down? The given. Okay, that gives you points. So we're trying to, we know that B is the midpoint of AC. So why could I write that down? It's given. Two points, writing the statement and the reason. Okay? So B is the midpoint of AC. Before we do anything else, we have another given that we're going to write down. But before we do anything else, let's ask ourselves, what does that mean? If B is the midpoint of AC, what does that mean, Logan? Very good. And not just in between them, but is bisecting them, is cutting them in half. Okay? So which two parts are equal then? Very good. Let's put a mark there so we remember that. And let's write it down. AB is equal to BC. So when you ask yourself, what does it mean that that's a midpoint, and you write something down, that's simply the definition of midpoint. Okay? We define the midpoint as a point that is halfway between those two parts, makes them two congruent segments. So this is definition, and you can write def of midpoint, and you can even abbreviate midpoint as mid-PT. Okay? We're not looking for perfect spelling or grammar or anything like this. We're doing a geometric proof. Okay? All right, so we had a given and a statement. Okay? So now let's go get that second given. Okay? So the next thing they told us was C is the midpoint of segment BD. Okay? So why can we write that down? It's a given. Okay? Now let's go to our drawing and see what that means. C is the midpoint of BD. Here's our C. Okay, if it's the midpoint of BD, what does that mean, Andre? If C is the midpoint of BD, what does that mean? It's the middle. So that means that BC has to be equal to what? Yeah, BC has to be equal to CD. When we say why does that mean that, it's definition of midpoint. Andre told me it's in the middle, which makes them congruent segments, right? Okay, now, this is looking promising. Because what are we trying to get to here? AB has to be equal to CD, right? Okay. And we know AB is equal to BC. And we know BC equals CD. So can we do something with these two to get AB equal to CD? Yep, think about circling those two BCs, right? They're on the diagonal from each other, right? So what does that mean? AB equals CD. What's my reason? When you can circle these guys, cross them off, and make these two. Substitution or transitive. This is a classic case of transitive. They all lined up on the diagonal, but if you put substitution down, I would not count it wrong. That's the better answer, though. Okay, so this would be a 10-point problem, possibly, right? Writing down givens gets you 4 points. Writing down what you're trying to prove gets you a 5th point. So you're half the way there, even if you don't know how to do anything else. 50% on that problem, right? So we always write the givens. We ask ourselves, what does it mean? And then we use our transitive, subtraction, addition, those types of things to make it happen. What questions do you have on this slide? All right. I think I had that up there twice, right? So we're done. So your assignment is a book assignment. Let me get it copied out and put up here for you.